Hey everybody, and welcome back to another fun and exciting Algebra 1 class. Today's lesson will be diving into lesson 2.8 in your books. That is on page number 69, and we'll be doing solving mixture problems. You might say, what is a mixture problem? Well, I'm glad you asked because you came to the right place to get the answer. All right, so a mixture problem is a word problem that requires finding the quantity of each type of item. For example, how many nickels and dimes does it take to add up to whatever, and they'll throw in some other things. How many 8-foot boards and 6-foot boards would you need to do a project? These are very useful in real life. If you end up being a carpenter, a builder, a somebody who bakes, a baker, anything in the kitchen, we deal with a lot of mixtures. Anything in building, anything in construction, those types of things. There's also other careers that will take you into different types of things that will use this type of problem, this mixture problem. So very useful, and also something that is going to make your brain think here. All right, so here we go. A 5-pound bag of almonds and cashews was sold for $12.40 per pound. If the almonds were $10 per pound and the cashews were $14 per pound, how many pounds of each type of nut were purchased? Okay. So in other words, notice the almonds were 10, the cashews were 14, and right here in the middle of that somewhere was $12.40 per pound. So we've got some sort of a mixture of almonds and of cashews. We don't know what the mixture is. That's the question. We're supposed to figure it out. All right, let's look at some of the things that the book tells us to do. First of all, it says organize the information into a table. That's going to help us. What's a table? A table is something that we're going to label. See, on one side you have the almonds, the cashews, and the total. The other side you have the quantity, how many of them, and what was the value, how much did they cost. And so you're putting things into a table. I don't necessarily need you to build the whole table out exactly like the book does, but have some way of putting it down on your piece of paper so you're taking it out of the problem, out of the words. What we're trying to do is basically reduce how confusing all of this is and put it into something that we can visually see. Okay? So we want to do that, and then we want to plug it into an equation and then solve it. So we'll look here at solving mixture problems at these 3 steps. So step number 1, make and fill in a table. Place the types of objects as the row heading on the left. Place the characteristics as the rows. Those would be kind of the ones that are on the top. And then represent one unknown. Remember, this is something we learned in the last lesson. We can only have one variable. You can't have C for cashew and A for almonds. You can't do it that way. You have to only pick one of them. So you have to only use cashews, or you have to only use almonds. And then you have to build something. The other variable is contingent on the first variable. You cannot have 2 variables. It doesn't work that way. And then represent the other unknown as a total minus of the variable. So basically what they're saying there is we're going to use the other variable as whatever our first variable is minus whatever the second variable is. Then we're going to write and solve the equation, and then we're going to state and check our answers. Basically the same thing we did in the last lesson, but this is just a little bit different because now we're adding one piece to that, and that piece is actually building a table. All right, let's turn the page here and look at some of these examples together. You can follow along on page number 70 as I do them here on my screen. All right, so we have our friend Marcy, and she has 33 dimes and nickels with a total of $2.50. How many of each coin does she have? Well, the first thing that we want to do is we want to kind of build out our little table over here, okay? So let's build a little table. So we have dimes, and we have nickels, and then we have our total. Okay. So you put a little line in each one of these. And then up here on the top, we're going to have our quantity, like how many of each one. So quantity. And then the other one is going to be what's the value of each one of those. Okay, so our quantity, and you could really choose whichever one you want. If you want your variable to be nickels, that's fine. We're gonna make our variable dimes, and so we have D for dimes. Let me change the color on that so you can see that just a little bit better. So we'll have D for dimes. All right, and then what we want to do is what is our value of a dime? Okay. Well, our value of a dime is 10 cents. All right, so 0.10 is a dime. And you might say, Mr. Steve, how did you know that? How did you know that a dime was 10 cents? Well, ask your mom and dad if you don't know how much a dime is, okay? You should know how much a dime is. It is 10 cents, and so that's why we write its value like that. Okay, so the next one is now not nickels. We're not going to write an N here for nickels. That does not work. We need to write it in relationship to dimes. The way that the book tells us to do that is write the total, which is 33 total things minus the dimes. In other words, if we take, how are we going to figure out how many nickels there are? Well, if we know how many dimes there are, we know how many total there are. We could subtract the dimes from the total, and that will tell us how many nickels there are. So that's the idea. Obviously, here in total, there's going to be 33 total. Now, what's the value of a nickel? Okay, a nickel is 5 cents, but it's not 0.5 times D, because that's a dime. It's 0.5 times the nickel. What's the nickel? The nickel is the 33 minus. So that's going to be our 0.5 times 33 minus D, which is our nickel. So technically our N equals 33 minus D. Our nickel equals this right here. So we don't write that necessarily, but you can if you want. If that helps you, go ahead and write what the nickel equals. The nickel equals 33 minus D. So the value of the nickel would be 0.5, because that's the value of a nickel, times 33 minus D, because we have to write it in relationship to the dime. Why? Because that's the one that we chose. Had we chosen the nickel, then we would be writing it in relationship to the nickel. And you could do that. That's fine. That works. All right. So what is our value total? Our value total. That's what we're looking for right here. We've got one more box to fill in. Well, our value total is $2.50. So $2.50 is what we want there. Okay. So now this is where we go ahead and start plugging it into an equation. Basically, you're going to take this information right here in the value column, and you're going to plug it into an equation that is going to allow us to solve this. All right, so what does that look like? Okay, well, here's what it looks like. We would just go with 0.1, and that's times D. So we're basically writing this. We don't need the 0. You could write that if you wanted to. D, and then we're going to add that to our dime. So this is our dime, so we're going to add that to our nickels. That's going to be next, and then that's going to equal our total. Okay, so our nickels is 0.5, and that's times, actually 0.05. My mistake, and let me add the 0 over here. So 0.05. 0.5 would be 50 cents, but 0.05 is 5 cents. All right, so, and that's going to be times 33 minus D, because we can't write N. So we have to write it in terms of the dimes, okay? And then that's going to equal $2.50, okay? Now, we have some decimals here that we're dealing with. Do you remember how we get rid of decimals? This was a lesson that we covered, I don't know, maybe in the middle of the first chapter, somewhere in there. So here's the thing with algebra. You have to continue to remember things even though we covered them a week ago, 2 weeks ago, a month ago, whatever it was. So what we want to do here is we want to take this and we want to multiply this by something, and that something is going to eliminate the decimals. What I told you was you always take the one with the most decimal spaces to eliminate. This one has 2. This one has 2. This one only has 1. So we're going to take and we're going to do it with 2 zeros. Why 2 zeros? So we're going to do it times 100. Why times 100? Because we want to eliminate all of the decimals. Okay. If we do it by 10, it's not going to eliminate this decimal and this decimal. So if we do it by 1,000, that's going to give us numbers that are too big. So we choose 100 because that's how many decimal moves we have. The number of zeros matches the number of decimal moves to eliminate the decimals. All right, so here we go. 100 times 0.1, that's going to move that decimal 2 times. That's going to be 10d plus, this is going to move it 2 times. And so that's going to be 5 times 33 minus d equals, it's going to move it 2 times. That's going to be 250. Okay. So now what we want to do is we want to go ahead and just continue to solve this. How do we solve equations? Do what you can do. We're going to multiply this 5 through here. So we're going to get 10d plus 33 times 5 is going to give us 165. You can go ahead, use your calculator if you need to there. Minus 5d equals 250. All we did was we distributed right here. Do what you can do. That's the first step to solving an equation. Now we're going to combine like terms. So I have like terms right there. I have 10d minus 5d. 10 minus 5 is 5d. And then I can also move this over to the other side. So minus 165, that cancels, minus 165 over here. And that's going to equal 85. 250 minus 165 is 85. Now I can divide both sides by 5, and I end up with d equals, and this is going to be our total number of what? D equals dimes. Okay, so D equals 85 divided by 5, and that equals 17. That's only part of our answer. There are 17 dimes, but now I have to go back to this chart and I got to say, oh yeah, we had to get nickels too. So the N, or the nickels, is going to be 33 minus 17. All right, so you do that, and you're going to end up with 16 nickels. So 16 nickels and 17 dimes is what it takes to get $2.50. Okay? Lots of stuff going on there. Right now, you're probably going, wow, that's so much different stuff. Yeah, but it's all things that we've been doing. There's nothing new there, right? The only thing new was putting it into this. So if you can put it into today's lesson, the only thing that you're really doing that's new is putting it into the chart. After you put it into the chart, then everything else is the same. Just then plug it in, then do your math. But you have to remember, and that's why algebra continues to build on itself, and that's why you have to keep up with it. So keep working hard and keep doing your best to remember all the different lessons that we've been doing. All right, here we go. Next one. So we have tickets to science fair were $4 for adults and $2 for students. If 850 tickets were sold at $2,620 was collected, how many adults and students? All right, so we just go back over to our chart here. And so we have adults, students, and total. Okay, so adults, students, and total. And then we just have 2. So this is going to be the tickets, and this is going to be I could call this the value of the tickets. Okay. And so and we base it, we always base it on one or the other of those. Okay. And so Um, let's use adults. Okay, so adults will just be A. Okay, you can make it X, whatever you want. The value of the adult ticket was $4. So 4 times A, 4 times the adult ticket. The student tickets, now we have to base it on the adult ticket. So how many total tickets were sold? 850. Okay. So we're going to say that this is going to be 850 minus A, and that's going to give us how many student tickets. Okay. How much was the student ticket? It was $2, so 2 times 850 minus A. How much total did we have? $2,620. And now we just put this information right there into our equation. So we're going to have 4A, and then we're going to have to add that to this. So that's our adult tickets. We're going to have to add that to our student ticket, which is 2 times 850, because that's how many total tickets we had, minus A equals the 2,620. Okay, sorry, got a little crunched in there. Now what we want to do is just go ahead and solve this. And so we're just going to go through our steps that we know how to do. Let me change the color here quick so you can see what's going on. And so we're going to distribute this first. All right. And so we get 4A plus 2 times 850 is going to be 1,700 minus 2A. 2 times A is 2A equals $2,620. You have a 4A and you have a minus 2A, so you end up with 2A. 4 minus 2 is 2. And then you subtract 1,700 from both sides. That cancels out. And we end up with equals this right here, and that gives us a 920. 920. Divide both sides by 2, and we have the adults that came. The adults that bought tickets are going to be 920 divided by 2, and that's going to give us 460. Now, to get the student tickets, we're going to take the total, which was 850, and we're going to subtract the 460, and that's going to give us 0. Borrow over here. We'll get a 9. We'll get a 390. So there were 390 student tickets sold, and we had 460 adult tickets sold. Now you could plug that back in and check it. I won't take the time to do that. The check is there in your book. All right. We will look at one more, and I'm not going to take the time to do this last one, but go ahead and look at example C. Mr. Higgins invested $50,000 in 2 ventures. One earned 9% interest and the other earned 10% interest. He earned $4,700 total. How much did he invest? So we're just going to plug it in again. So if you notice, we're going to set up our chart. One was at 9%, one was at 10%, and then our total was 50,000. We just chose one. Didn't matter which one we chose, and we called one N for number. And then we multiplied that times the 0.9, plug that in, do what we do there, just like we did in the first one where we multiplied it to get rid of the decimal, and then move your stuff over to the other side, divide by 0.01, all the things there that you can see, and we end up with our 9%. We invested $30,000 into that one. And so then that would mean that our 10%, we invested $20,000 into that one. Okay. The key to this deal right here is you have to do your chart. Once you get your chart, it's fairly easy. Then you just plug that right side of the chart into the equation, and then the equation, you should know how to do equations. If you don't know how to do equations yet, go back and study those lessons, rewatch those videos, do some of those practice problems. But it should be fairly easy once you get it into the table. Plug into the equation, solve the equation. Don't forget to check the equation, and then you should get the right answers from there. All right, that's all I've got for you. Hope you learned something there. If you missed anything, slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.